for doing it.
Hi there, this is John Bishop, and I'm here with my good friend, Dr. Nancy Flournoy, and we are both the Lifewave independent distributors. And today, Nancy is going to get a very in-depth webinar presentation on the Silent Nights patch, and also help us to understand a little bit how important sleep really is. Some of us, probably know that it's important, but really, I think we're going to dive pretty deeply into the whole mechanism of our sleep and how we can benefit, by getting certain things such as melatonin, right? And that is very important. So without further ado, I'll turn it over to you, Nancy.
Okay, thank you, John. I will share my screen.
Should be ready to go.
Yeah, I see I think this will do it.
There we go.
How does that look?
That looks perfect.
Okay, let me get started here. So I'm Dr. Nancy Flournoy, and I'm pleased to be here with you today. I have been giving a series of talks on the different Lifewave patches, and they've been a great way to learn about what the patches do and why they are set up to do what they do. My field of interest is clinical trials, and my PhD is in statistics, and I have spent my career in the sciences, but there's been a lot of biology that has been learned in biochemistry and biophysics in the last few years. And so I'm catching up, and I invite you to join me and learn as we go. I am a Lifewave distributor, and my website down here, lightpatchscience.com, is available should you want more information or information on how to contact me. So first, the patches themselves are innovative and non-transdermal. They have photonic and electrical properties. So basically, they're a new nanotechnology that's wireless, and the little patch looks like a little Band-Aid, little circular Band-Aid, and it has a crystal on it, organic crystal, and those crystals absorb infrared frequencies from your body and then turn around and emit certain spectra back into the body. And those spectra are designed to enhance electrical conductivity in the skin. So they're a new method of stimulating acupuncture points and the larger bioelectrical system in our bodies. They reflect a narrow band of frequencies as compared to what you get if you use a standard infrared product, which is not only big and clunky, but also does a broadband reflection rather than being specific. So placed on your skin, these patches transmit specific wavelengths that are designed to optimize certain functions, such as in the case of our talk today, sleep. And on the right hand, you see there the company's recommended places on your body for putting the patches. And we'll talk more about patching in a little while. So first, it talked about I just mentioned that the patches stimulate the electrical properties in the skin. And in particular, the skin has a lot of collagen. And collagen has both piezo and pyroelectric properties. That is, the crystals, the skin has crystals that are largely composed of water. Collagen has water crystals in it, and they can act like a battery under force and create an electrical charge, or they can react to heat and create an electrical charge, or an electrical charge can come in, say, from a Lifewave patch and going in the reverse way, create force or heat. So this is a large electrical system that covers our body that the patches tap into. So let's talk a little bit about sleep. So what are the problems with sleep? Well, hundreds of years ago, we people, Americans, slept an average of 10 hours a night, and we adjusted our sleeping time to the daylight. Today, a lot of people sleep no more than 5.5 hours per night, and they don't even think that's a problem. And alternatively, there are lots of studies that say 40% of people report they have significant problems with insomnia, and they know they have a problem. So what's the problem with insomnia? Well, in a month or less, it can lead to excessive sleepiness at work, so you become not so very functional. It can bring on mood disturbances, increase the errors that you make in your daily life, increase accidents, and family and societal problems. And if you go on to become a chronic insomniac, then you have a higher incidence of, there's a whole list of diseases here, which accumulate in separation, divorce, and death, and nothing that anyone wants to have. So sleep it's critical to get good sleep. Now, here on the right-hand side of this slide, you can see that just the way you sleep matters. That is the time of day. So if you are not working, if you're a working individual, and you don't have a normal 8 to 5 work time, then you are at risk. If you have the evening shift, you're at an increased risk for illness. If you have the night shift, it's worse. And worst of all is when you have one shift one day or 1 month, and then you have another shift the next day. So there's no continuity in your in when you're awake and when you're asleep. Now, there are drugs on the market that are used regularly for people that have sleep disorders. And there's a bunch of them that go under the title of benzodiazepines. And these work by blocking excess activity of the nerves in the brain and other areas of the central nervous system. So, you're really playing with I'd like to say playing with fire when you start just bringing in an external force that's not natural, that's going to start messing around with your nerves and your central nervous system. So in this particular stage in the particular case of these compounds, they interfere with stage 4 sleep, which is particularly what you need to have. So they help on one hand and they don't on another. And then often people are given antidepressant drugs, which stimulate melatonin secretion. And we're going to talk more about melatonin, but the drugs then have undesirable side effects when they're given just to treat insomnia. And you don't really need them for depression or the things they're basically intended for. So these drugs often lead to a feeling of hangovers and sleepwalking and driving and other activities while you're actually asleep. So they can be dangerous. Now, there are melatonin supplements, which we've probably all heard of, and they're not uncommon side effects of headache, dizziness, nausea, and drowsiness. So it's also true that even though melatonin is consistently reported, melatonin as in the supplement is consistently reported to have benefits, it and its analogs on sleep disorders, the effects that are reported are of low strength, and most of what's in the literature are guidelines based on narrative reviews. There are very few randomized placebo-controlled clinical trials. So now we don't have, Lifewave has no randomized placebo-controlled clinical trials to add, but they have the studies that we will talk about are, even though I would like to see more, they're in line with what's out there, which is really surprising given all the attention melatonin has gotten in the popular press and popular conversation. So what about insomnia? So it's not just sleep disorder. Associated with chronic disorder, we will be talking mostly about the circadian sleep-wake rhythm disorders, focusing on melatonin, because it seems quite clear, although it is never specifically stated, that the Lifewave patch is designed to increase melatonin. There are hints of that in the reports from the studies that have been done, although as I tell you, I could not see it explicitly stated by the company. Other things that are associated with chronic insomnia are psychiatric conditions, and there's a list, and medical conditions, and neurological conditions, and medications. So having trouble with sleep can be a complex thing to combat. Now, let's look at melatonin. Well, first, it's a hormone that's produced by the pineal gland. We have my husband and I have a nutritional biochemist that we've worked with for years. And when they started first pushing melatonin supplements, he raised his hands in horror because he said that they've never yet given a hormone directly as a man-produced, chemically manufactured hormone directly without having serious side effects show up later. So I will just say that hormones are very powerful components of our bodily function, and here one has to be cautious if one's going to take a supplement. So naturally, it's produced in the pineal gland. And if you look at this little picture here on the left, you see the brain, and the pineal gland is right in the center of the brain, kind of behind the ear if you poke right through. And that's where melatonin is made. And it regulates your wake-sleep clock. And the wake-sleep clock itself then influences the secretions of other hormones. So you can see from moving into the hypothalamus, it then affects the pituitary gland, and it affects growth hormones and the adrenal glands and cortisol and DHEA. And it has a feedback loop to the pituitary gland and a feedback loop to the hypothalamus. So so although what we're talking about is sleep, which is this first item that is controlled by the sleep-wake clock, that is controlled aside from all those things that we looked at on the previous slide that might get in the way, melatonin itself does have quite a number of other influences through influencing other hormones. So here on the right, we have a picture of what the concentration of melatonin looks like in the plasma as a function of hours of the day. And the gray here is to mark when the sun is down. And you can see that there's almost no production and then a big rise and fall with the dark hours, and the width of that production interval changes with the length of the day as it changes over the course of the year. So as I said, melatonin is produced by the pineal gland. So just comment on the pineal gland, which Rene Descartes called the seat of the soul. And its main function is to receive information about the state of the light-dark cycle from the environment and convey this information to produce and secrete the hormone melatonin. So it has some other functions too, which we won't talk about, that are important, but it is key. Its key function is to keep us on a good cycle. It takes its signal, it gets its information about light and dark from the retina into the pineal gland. In less developed animals, the pineal gland is actually photosensitive and can detect light itself. But in humans, that sensitivity has gone dormant, or we've atrophied, and it must get its information about light from the retina of your eyes. So melatonin, well, it synchronizes central and peripheral oscillators. So by oscillators, we mean things that go up and down. And that is the thing, a number of organs have their functions oscillate. They're more active at some times of the day than at other times of the day. You also have like the menstrual cycle, which goes on a monthly cycle. So melatonin has its role in keeping all of these activities in their proper place temporally. So they organize, melatonin organizes the biological functions through the circadian rhythm in relationship to periodic environmental changes. That is the day, the length of the day, the time of the year, and thereby it helps the individual to adapt to the external environment. Now, aside from directly affecting the time of the day and sleep, which is the general focus of this talk, it has other functions as well. It signals for cell protection and repair in response to UV radiation and cytokines and other damaging external things that come to the skin. It'll activate death genes, which are those that want to go clean up the cells that are, the genes that need to die and be replaced by new genes. And so if they need to die, they need to go, and the melatonin is going to activate that activity. And in contrast, it's going to activate the proliferation and activation of survival genes. So it has a lot to do with deciding whether your gene is going to die or not die. And we can talk more about that in connection with other patches. Another activity is neuroprotection against oxidative stress, which is, we have another episode in which we discuss oxidative stress. So melatonin's has more functions, has a lot of functions, and it's a critical component of our well-being. Now here's a couple of pictures on its pathway. So first, I just looked down at the picture. This is what the melatonin molecule looks like. And the gray, the backbone of all of these molecules is carbon. So these big gray molecules are carbon. And here we have a tetrahedron, and here we have a sextahedron. And that's kind of the backbone. And then we have these strings of things that are off both ends. And if you are interested in the chemistry, this is kind of a good example to see its synthesis from the pineal gland, because these two circles in the middle are really constant up here, starting with tryptophan. So we start with these carbon rings with a few things hanging off the end, some nitrogen and hydrogen and some oxygen. And as we go through the development, we add hydrogen and oxygen on the left, which stays on all the way down. And then this stays the same. And when you get to serotonin, this series of atoms that are hanging off the end sort of rearrange themselves and change a little bit. And then they change a little bit more. And then you get to melatonin, And so, there's not a huge difference from the beginning to the end, but they're critical in terms of what these molecules are going to do. Now, the picture here with the blue and the orange is more sort of a practical description, going from food down to melatonin and showing you which vitamins and minerals you need to make those transformations in the molecular structure happen. And one thing to notice is that there are 3 different B vitamins you need to do this. So it's in some ways, it's a very simple operation. You just change a few molecules on the ends of these rings, and yet it's a very complex operation. And we need to get it right. So this is a collection of facts about melatonin. Once it's synthesized, it's released directly into your blood, into the circulation system, and into the CNS without getting stored. It's not packaged away or saved. The melatonin you use today, you make it. It's got a half-life, which means half of what you have produced that's gotten into the blood is going to be gone in 40 minutes. So there's no reservoir there. You need to make it every day. It is not only it's found largely in the plasma, but it also is in the saliva at much lower levels, and likewise even lower levels in the urine. In the urine, you can see it being excreted. It's interesting, it very easily crosses the cell and nuclear membranes. So we can get around and go where it needs to go. One of the ways it operates is to bind to particular sites. And then the fact that it's linked up with something else causes a reaction. So it binds to a number of places in the brain, and here's a list. And this one site, the pars tuberalis, is our clock, where our clock genes are. And also clock genes are also in this complex called the suprachiasmatic nucleus, which is abbreviated SCN. And it should be noted that the central clock of your body, which is independent of this SCN, can be affected by the availability of food, temperature variations, forced activity and rest, drugs, including melatonin itself, and timing. So there's a lot that goes into our clock. The melatonin will bind to cells of the immune system, the gonads, kidney, the cardiovascular system. I'm sure there's a lot more to learn. It has antioxidant properties, which are not cell mediated, which we referred to earlier, and then it's disposed of by going through the liver. So let me turn now to some of the research that's been done on Silent Night patches, that is on the Lifewave patches themselves. And what we can learn from that, it's only two studies that are in the resources section of the Lifewave company website. The first one is done by, that should be Norman Shealy. In 2011, a very famous doctor, if you haven't heard about him. And then there's a study in 2013 by Melinda Connor and a colleague. So we'll discuss both of these. They're both small studies, not very many subjects. So first we have the study by Melinda, and she does a lot of different tests. There's just hundreds of measurements and almost no subjects, N equals 5. Now, it must have been very expensive to do all these tests because it's very hard to draw hard conclusions when you have a lot of tests and a very small sample size. The problem with having a lot of tests is that, and they're doing going through the process of doing statistical calculations, is that the probabilities are such that you're going to end up with some spurious, quote, significant findings. That is, just from random chance, something is going to be to seem noteworthy. And that means you have to take all of the things they say are significant with a grain of salt. On the other hand, with n equals 5, you have to have a pretty big change in order for a particular finding to reach this level of significance. So of all the things that she studied, I highlighted things where she found some indication that the patch is having an influence. And one of them is neurotransmitters. I'll say another, I have another slide on neurotransmitters. And I should say here it says no significant change seen for amino acids and hormonal samples. I mean, that's one of the reasons that it's really sad to have a study such as this done with so few samples, because you also have what's called low power, which means that there's that you can have some clinically meaningful effects that you're just not going to see with so few subjects. And so you can't really write off the things that she's found, she declares are negative results, because it might just be a consequence of the fact that you only had 5 subjects. So taking all of that into consideration, we then interpret these as enticing, exciting, perspective, consequences that should really be explored in greater detail. So one of them is neurotransmitters. One are the results from the gas discharge visualization device, which we have talked about before. Heart rate variability, we've also talked about before, and I think I have something more to say about each of these. And then on a bunch of questionnaires and self-assessment scales, there were changes in the sleep scale and the profile of mood. So looking at these a little more carefully, same study. Oops. So after a week, again, it's pretty clear that melatonin was the target. And they don't really have a reportable result for an increase in melatonin, but they did get an increase in serotonin. And if you remember that pathway chart, the diagrams that we had, serotonin's a precursor of melatonin. So if you have more serotonin, unless your manufacturing system's really messed up, you're going to have more melatonin eventually, either with more time or with more subjects to be able to establish the consequences. So this really should be followed up on with more time and more subjects. But they did see an uptick in the serotonin. And even if it turns out that the effect of the patch doesn't actually reach into melatonin production, this is a good big thing in and of itself, in that serotonin is a major neurotransmitter, which is a molecule that allows neurons to communicate with each other, which is definitely important. So in fact, she found the production of most neurotransmitters at all the time points that they looked at to be significant. And I have another slide on neurotransmitters. So with respect to heart rate variability, if you remember from our previous talk, one might think that heart rate variation would be bad. You want your heart rate to be nice and stable, but it's actually a sign of resilience to have variation in your heart rate. And one of the parameters that goes into this measurement of heart rate variability is temperature. And the findings that came out of this study are consistent with what you would see at the beginning of downregulation of stress parameters. So here's an indication that melatonin is going to have a positive effect on stress, on decreasing stress. So I have got a reference here for the fact that the heart rate variability is significantly greater in healthy, relaxed people rather than those that are emotionally stressed. Now, GDV, this is the gas discharge visualization data, and her results support the downregulation in stress from that data as well, particularly in the area of the hypothalamus, which we saw was really important there with respect to other hormones, the nervous system, and the thoracic area of the polyvagal system. So these are pretty important and intriguing results. They also had an increased feeling of well-being, and the way this phrase is written, it's a little more complicated than it needs to be. So they definitely need a larger study to make these findings more concrete and more solid in terms of the scientific community. So let's talk about neurotransmitters. She said almost all the neurotransmitters are affected. So I went through the lists that she had, and it's a long list. And at first, she said no significant changes were observed for, and there's a list of molecules. But you know, they did it day 1, day 3, day 4, day 7. And so what we have in this list, like if you look at glutathione, it's not every measurement that did not change. It's no change on this particular measurement from baseline to day 3. So that means there was a change to day 7, and there was a change to day 1. And again, all of this could be, since there was some sometimes and some others, that could be just the variation from having such a small sample size, or in either direction. So you can't really write them on or off. It would be much more negative if she said we saw no changes at all in any of the measurements. You know, then okay, you might say that doesn't look good. But here it's mixed. Whereas on the left, we have a list of things for which the measurements were all at all time points were positive. And so some of these you may have heard of, and some of them you may not. And sometime maybe we'll do a talk on all of the neurotransmitters in more depth. I won't go into that now, but the adrenaline, we've all heard of adrenaline. There's this thing called CRE, which has, takes care of the spatial and temporal control of gene expression. Dopamine is essential in the brain and the body for movement, pleasure, motivation, memory, attention, very important. GABA is a primary inhibitor between the nerve cells in the brain. Histamine, well, anybody with allergies has some experience with histamine. Melatonin, we've been talking about. Metanef, I could not find anything interesting to report to you about it, so I need to research that a bit more. And NAD, which is a compound that we hear David Schmidt, the CEO of Lifewave, talk about very often. And so we should pay attention here. NID is a fundamental component of various redox reactions. So redox, the ox stands for oxidative, and those reactions are where electrons get exchanged between different chemical species. So they have to do with oxidative stress and with the transfer of electrons, which is really a fundamental part of all of our biochemical reactions. So this is quite an amazing list. Now this really stumped me. This is in Melinda's paper, and I don't know what to make of it, because she says Silent Night, the patch, has the following formulary. Well, we know that the patch doesn't put anything into the body, and yet what we see here are a lot of components that might be used in different kinds of healing packages. You might have them in tea or in homeopathics or something. And all I can speculate is that what she's saying is that the Lifewave crystal contains these things. And this would be something that really be nice to ask David about, because we've really not had any information previously, or aside from this hint of what the Lifewave crystal is actually composed of. So she she even tells us that, each ingredient has the different potencies, and refers to it in the kind of language that one would refer to a homeopathic. So it's very possible that the Lifewave crystals have are made up of these ingredients. So we will see what we can learn about that in the future, because that way we could look for other formularies for other patches, and get some very interesting information, I would think. Now, the second talk, and again, I don't know, I guess I must have cut and pasted. This is Norman Sheely, and he's looking at treatment of insomnia particularly. He had 20 subjects, so that's better than 5. And whereas Melinda looked at basically healthy subjects, he's looking at subjects who are suffering from insomnia. And he's studying them by questionnaire, self-report. And there's a long list of questionnaires, standard questionnaires that he gave the subjects to complete, both before they got patched and after 30 days. So I'll say a little bit more about the acupuncture points that they used. They assigned individuals to the acupuncture points, and if they did not sleep adequately on the patch they were assigned to, they could rotate through them until they found one that helped them. So here are the patching points that they used, and again, it's interesting to look at what these acupuncture points are designed to do, to sort of reverse engineer what was David's intent and how he designed the patch. So LV3, liver 3, is commonly used for insomnia. Well, that's pretty clear relationship to what we're talking about. And then well, stress and anxiety are on the list, and a few other things. And stomach 36 has also is known or used. I'm not sure about the research on this. I just tell you what the acupuncture literature has to say about it. The stomach 36 also is used to reduce stress. The GV 24.5 is the third eye, and it calms the mind, clarifies ideas, strengthens mental projection and intuition. So calming the mind might calm everything else and let you sleep. That makes sense. And then there's the triple heater meridian, of which this is just the top part shown here. And I guess more recently, it's now called the triple warmer meridian, but it's the same thing. And they use the points 17 or 23. And 17 is right behind the earlobe here. And 23 is up by the eyebrow. So the triple warmer meridian controls our fight, flight, or freeze responses, and therefore presumably is involved in adrenaline, and we would certainly not, that would not be good for sleep. It impacts the immune system and our ability to manage stress, so it's a stress-related meridian. When it's activated, the body's on high alert, and it can calm or sedate the flight or fight response. So all these points seem pretty, seems like there's a reasonable reason to think that they might be effective for producing sleep. I mean, unfortunately, there's so few subjects that you couldn't, I mean, it would be nice to have a group of subjects on each of these and then to compare and contrast, but we don't have that. So just to summarize his results from all those questionnaires, he gives the numbers on everything, but his summary is that they improve the quality of sleep, the length of sleep, and decrease daytime sleepiness in 72% of the 25 individuals. I calculate that's 19 individuals. So this is interesting. Of the 25 individuals who entered the study, 9 had a score which suggests clinical depression. So that's serious. And 7 of the 9 had reductions in their depressive score at the end of taking the Silent Night patch. But he suggests that depression and total life stress were not nearly affected as much as the sleep studies themselves. So in the end, the primary benefit he sees is the sleep, and then the benefits you're going to get from that. I have a few references. I should have listed more. And I thank you very much for joining me in this journey of discovery. My website is lightpatchscience.com, and I will turn it back to John.
Thanks, Nancy.
Thank you.
Very good. Very good.
They never fail to surprise me, these investigations that I've done. It's actually, as you said, we have one more to do. Which one do we have to do besides just the first patch, right? Just the AccuLife patch. And then we will have done one on each. I will have done one together. We've done one on each of the patches. And I really do look forward to going through them again, because in having gone through them all now, I have a pretty good understanding as to who the researchers are that have been involved and what they bring to bear and what they can offer, and have a better idea as to the parts of biology and biophysics and biochemistry that David's focused on. And it'll be fun to sort of redo everything now that we've been through it all once. So I hope our listeners will come back again when we start over. Next week will be AccuLife.
That's right. Okay, so that was great, Nancy. So people watching this recording today, I'd just like to mention that all of the all of the Lifewave patches come with a 90-day money back guarantee. That means you can use the product if you're not satisfied. The company has this wonderful 100% 90-day money back guarantee, which is really kind of unprecedented, as you might expect. So yeah, I just wanted to say my personal experience with the Silent Nights patch has been really kind of overwhelming, because I probably in the profession that I'm normally in, I would kind of categorize myself as kind of a night owl, and also having a very difficult time sometimes to get to sleep. And since whenever I use the Silent Night patch, it's just pretty much every day. I just put it here on right between my eyebrows here, and my sleep in the last year and a half has probably been better than it's been in my entire life. I can really say that the Silent Night patches deliver on what they say, and it's just it's kind of science is great. Science is wonderful. It's good to discover these things. What I tell people is as much as you know about the science, and however something might sound good, the best way to really be impressed with this company is to try the patches.
Absolutely.
That's the game changer right there, is trying the patches out for yourself and see what happens. And nothing does
And
happen.
it's a lot of fun.
Yeah, playing.
It's a lot of fun, and it's so nice to feel better.
Yeah,
and to feel younger, and to feel.
And that's important. Yeah,
I should say I'm 74 years old, just for the record.
Right.
Feeling good. I like those patches.
Yeah. So thank you, David Schmidt, for inventing this.
Yes, thanks to David. Thank you, David.
Okay, so we'll say goodbye until next week.
Okay, thanks, David. Thanks, John. See you.
Thanks, Nancy.